SIR models are used to fit empirical data to find parameters that characterize the transmission rate of COVID-19 and other infectious diseases. The parameter output is the basic reproduction number, R0, or the rate of transmittance. Human behavior, weather, and environment can influence this. R0 is the product of beta, the infection-producing contacts per unit time per infected person, and tau, the mean infectious period that a person is infected. Beta depends on things like human behavior, social distancing, environmental factors often influence that. Population density and use of PPE and other mandated protocols do as well. The lifetime of the virus also influences beta and depends upon things like temperature and relative humidity. How long a person is infected is also dependent on their environmental conditions, as it leads to different comorbidity factors. The lifetime of the SARS-CoV-2 virus on surfaces has been assessed to some extent and found to be dependent on relative humidity and temperature. It's believed widely that it also depends on sunlight, and it's not known if other pollutants either enhance or suppress the viral load on a surface. NASA data can help us understand this transmission rate better. We can take the data for various regions, take that empirical data for region and season, and fit the R0, beta, and tau values, and then associate that with the season and weather environmental metrics that we derive in part from NASA satellite imagery. Then we can perform multivariate statistical analysis to get a predictive model of beta and tau based on environmental factors that are easily measured. NASA publishes a wide variety of environmental and weather data to be evaluated to find which factors matter, which don't, and come up with that mathematical model. Thus, NASA data can help us build a predictive model of the probability that a person is going to be infected based on their behavior and the environmental conditions. From this, we can actually create maps that will enable a user to lower their probability of infection